Okay, I want to say thanks for joining us, Francis and your name I now hear Uday and Dom from Planet, and this is going to be a presentation for our Geo for All group this Friday. So thanks guys for showing up, and thank you to Dr. Luciano Sierra Suchi for putting this together from the Precision Agriculture Department. Really looking forward to this. And I think Uday will start us off. So thank you. And I'll mute myself now.
Awesome. So welcome everyone. Excited to kind of talk about Planet today. The focus of the presentation will be predominantly around Planet and science application. So just kind of learning about how Planet imagery is integrated within research. We have around 900 publications that have been published within the last 4 years, and there's a new publication coming out every 48 hours. So it's really exciting to see researchers globally integrate Planet imagery into their workflows, and really starting to acknowledge and realize the value of near daily imagery. So mission one, when our company was founded, the founders believed that this was the mission that they wanted to initially work up to in the immediate kind of 8-year, 5-year timeframe. Planet itself was founded in 2010. And then mission one basically represents our company wanted the ability to make near daily change visible and accessible and actionable for researchers, governments, commercial companies, and kind of bring data and remote sensing data and satellite imagery to the world the same way Google Maps is kind of readily available for folks around the world. So this image right here, or this visualization, is describing how our satellites image. So we have around 140 bread loaf-sized CubeSats. Imagine like the size of a cereal box of a satellite. We have about 140 of them orbiting in the sun-synchronous orbit, taking photos in a line scanner kind of methodology. And then in addition to that, we have 15 high resolution satellites called Skysats, and those will pop up right about now. So you'll kind of see we have 15 of them orbiting in that same sun synchronous orbit. And then we have 6 additional Skysats that orbit around a mid-inclination orbit. This is exciting because it enables Planet as a company and as a group to really have the ability to image any spot in the world at nearly any time. Kind of just highlighting the masses of data that we cover. Nearly 15 terabytes of data per day is downlinked. You're talking about 4 to 5 images across the globe on a near daily basis for every week, which is really exciting from a research standpoint because it really enables you to have the ability to see things happening before, see things and events as they're happening, and then seeing the follow-on following those events. So here is an image from our latest dove constellation, the super doves, and you can kind of see the beautiful image that kind of shows the difference between urban infrastructure. You have agricultural plot fields in this bottom corner over here, and you can see river formations, as well as even some individual figures and ships that are following and in the river themselves. Here is a multispectral red edge / surface reflectance map of a delta, specifically within Ohio, I believe. And it just highlights, the sedimentology, the turbidity kind of changing, as well as the delta and watershed within the area. And this map itself is identifying vegetation and NDVI specifically. So Planet itself as a company has made tremendous improvements within our constellation system. So we have the PlanetScope constellation, the 140 CubeSats that I was talking about earlier. There are 3 generations of PlanetScope satellites within that. So kind of treated as 3 different instruments from a research standpoint and perspective. The initial PlanetScopes, when we initially launched them, had issues with the spectral resolution in the sense that you have bleeding from the blue band to the green band to the red band, as well as a very wide near infrared band. This made it very difficult for researchers to start initially using our data in the 2016-2017 timeframe, simply because the spectral characteristics weren't really in line with the Sentinel characteristics, which you can see down here. Planet's made tremendous strides and improvements in the sense that now we have a full flight and I think around 80 superdoves, which is the most recent edition of our planet scope. And then we have the dove-Rs over here. The exciting part about the improvements, though, are the kind of narrowing of the individual bands that you previously saw. That one, they align very well with the Sentinel bands, which really enables users with the ability to kind of do spectral analysis as well as data fusion studies. And then the addition of a coastal blue band over here, a second green band, a yellow band, and then a red edge band. What's really exciting about this, especially when you talk about coastal erosion, with the coastal blue band, you have the ability to kind of see aerosol particles within coastal areas and environments, as well as even track whales. With the second green band, you have the ability to kind of zone in on new vegetation indexes, as well as develop a greater understanding of the kind of general vegetation in kind of marine environments. You have the yellow band, which is wonderful for sedimentology and turbidity analysis, and then the red edge band kind of for your more sensitive nitrogen fertilization functions. So kind of seeing the addition of these bands has really enabled researchers to extend and expand the scope of what they're able to do previously. So Planet captures the Earth's entire landmass on a near daily basis. It really does give users the ability to see every spot of the world, regardless, and outside of the open ocean, and remote parts in Antarctica and the Arctic. We have relatively really good coverage globally, which is really exciting because it gives researchers a platform to kind of create these very time-dense, high temporally resolved research publications. So I'm going to skip through this. So this is our Constellation and Payload systems. So the payload system to the left, the Rapid Eye Constellation, was recently retired in March 2020. But what's really exciting about Rapid Eye is it actually imaged from 2009 onwards. So it gives researchers the ability to kind of create these time-dense series and analyses. And then you have the PlanetScope constellation that we were kind of talking about earlier, the bread loaf size cereal boxes that I was kind of mentioning. We have around, I believe, around 180 of those to 200 currently, because we just had a SuperDove launch. And we're at about 80 SuperDoves, which is really exciting. And then the final constellation is our high resolution constellation called Skysat. What's really unique about Skysat is it's one of the few high resolution systems that folks and researchers have the ability to get their hands on and also kind of zone in on their research study sites with sub-meter resolution. Typically it's, you pay for a subscription service, but you don't have the ability to necessarily focus in and know exactly when you're receiving your images. The unique part about Skysat is it gives researchers that ability. We actually have Cornell's Agritech Institute currently using our Skysat constellation, as well as I believe Michigan State University used it for archaeological research, and then we have Cornell University as well using it for archaeological research too. So really exciting and innovative stuff specifically within urban infrastructure and social kind of human geopolitical monitoring with the Skysat constellation. So just kind of skipping through this. All right, so getting into the research and kind of the content aspect of the presentation. So this study itself was really innovative and interesting, where the researchers themselves used planet imagery to track marine plastic that was accumulating on the coastline of the Gulf of Honduras and Bay Islands. This was a really interesting study where the researchers essentially used the spectral differences in plastic that was kind of conglomerating along the coastline, and then used and ground truthed it by going to the physical sites to evaluate if the plastic actually existed. It was really a unique study, very interesting, used innovative remote sensing technology to solve one of the world's largest climate issues. This other study also, was really captivating, and again, another COVID influence study. So this is essentially what you're looking at here is Venice. And within Venice, you have kind of the canals, and you can see to the left over here, there's dense sedimentology and sediment movement within the base of the canals. But during the lockdown, there was a stark change and substantial difference in suspended sediment and solids within the canals. And you could see the canals themselves starting to clear up. Marine life started to re-enter the canals during the lockdown period. So kind of just this market change and using planet imagery to essentially evaluate this was a really unique methodology, as well as usage of the data to understand the before and after during COVID. Here's a really interesting study that was done in the port of India. Specifically with this study, the groups used planet imagery to identify vessels. And then they ground truthed this with Google Earth imagery and then also on the ground monitoring and observation. They were essentially able to use PlanetScope imagery to identify smaller fishing vessels, and we're using some interesting methodologies to kind of achieve this. So you can see here's kind of a follow-up. They essentially used a neural net to identify the changes in kind of fishing vessels in the area. And during the peak of the lockdown, the area of the boats actually that were kind of resting on the dock increased substantially to a point where it was well past capacity comparatively to prior to the lockdown, where things were running a little bit more normal and people were out and fishing more regularly and frequently. So interesting linkages that you can see with economic activity inspired by the lockdown. Another really interesting study here where the group used a neural net to essentially identify cars that were on the road and identifying human traffic. So this was really interesting because they essentially used this innovative methodology that tracks and creates bounding boxes around highly dense areas, and they used 3-meter resolution to do this. Obviously, with the resolution, there were stark limitations. There was around a 68% accuracy rate of detection, but that being said, the existence of these types of methodologies for countrywide scale operations suggests that there might actually be potential to scale this in a way that it suggests large macro level trends rather than micro level trends. So here's a common use case that we see within the commercial space actually, and is very of interest within the research community as well. A lot of forestry institutes, industries, agencies, organizations globally are deeply looking into this. And one of the major causes of fires are actually dead trees kind of just remaining in the vicinity as additional fire fuel. And one of the problematic issues and kind of problems is that there is bark beetle disease, as well as just general pest detection and pest disease within the areas. With Planet's near daily solution, it enables folks to kind of zone in on their fields, understand change early on, and track the problem and stop it at the source. What's really interesting is this, methodology kind of is used globally, but it's not used with the same temporal cadence that agencies that are using Planet are actually tracking their large scale forest areas with. These groups have cited that they've had the ability to kind of stop these problems at the source, kind of reduce the damage and impact that you see with the fire season, and really kind of hone in on, the ability to understand change and understand when something is a problem and treating it proactively rather than reactively. Here's another really interesting, image where you can kind of see the development of algal blooms. So this paper itself, you have this here, and then it's on Lake Erie in July 27th. And then you see a stark difference with just a matter of 3 days. So in the wetlands areas around Florida, we tend to see a lot of researchers zone in with planet imagery to understand the development of algal blooms. And it's actually quite a really interesting, the aquaculture market in general, I think is a very understudied and interesting market that is very applicable and well fitted with remote sensing technology too. So here's one of the projects that I think our entire organization as a whole is very passionate about, is the Allen Coral Reef Atlas. So this is Dr. Greg Asner's group out of ASU, and they work in conjunction with the University of Sydney and folks from the Australia, I think New South Wales government specifically. But the Allen Coral Atlas is really interesting because they're creating a map of coral reefs globally. And they do it to monitor coral reef health over time. They're using planet data in conjunction with vessel data that they're tracking and taking on their own, kind of their own in situ measurements. And it's essentially a map that evaluates the coral health globally. It's really exciting because with a lot of coral reefs, the water is clear enough where you can kind of see it using remote sensing technology. And when you talk about using kind of the near infrared band to evaluate these changes, you can really zone in on some of those. You kind of see over here the differences between healthy coral, stressed coral, and bleach coral. And then the map itself is the Allen Coral Atlas. And then over here, you can kind of get differences of data as well as an understanding of what the benthic classes actually are. Here's also another study done by Dr. Asner's lab, the forest carbon monitoring system. And it's actually a technology that you're starting to see with companies like Salo AI, Pachama, where they use LiDAR data to basically derive a baseline carbon stock dating or mapping, and then essentially use planet data to model the carbon changes and forestry changes. So they basically do a baseline measurement of carbon, and Dr. Asner did this in 2011 to 2013. And then he used planet data to essentially evaluate the change in deforestation and essentially creating a carbon stock emission calculator. What's really exciting about this methodology is, with the findings, they were doing comparative studies from 2011, 2013 with the LiDAR data to planet data that was taken in 2017, 2018, 2019. So there's a stark time difference that obviously contributed to a lot of the error that they found within the study. Now, with an updated recording of the LiDAR data itself, you'd start to see a study that has data that actually, is very accurate and aligned with the appropriate representation of what carbon actually is there in the area, as well as what actually exists. With the kind of USGS and NASA's recent LiDAR missions to update open source LiDAR globally, in the States, you'll start to see these methodologies expand into places in America with relative accuracy. And I think it's really amazing because planet data can serve as that temporal component to really understand those changes. And then you have these updated LiDAR measurements, which really give you the ability to create some really unique findings. So kind of diving into more so the ag focus section, props to Luciano. I did mention that I'd kind of dive in a little bit more about this. So Planet works with Corteva. It's one of the largest digital ag platforms. They have the digital ag platform being Granular. But what's really exciting is they integrated Planet imagery to essentially evaluate crop health, as well as kind of guide precision irrigation and other drivers that they kind of associate being valuable towards farmers. So with Planet's imagery, they were able to essentially detect irrigation in order to help and produce, greater crop yields essentially. So you can see these NDVI kind of surface reflectance maps over here, which kind of show the before and after. Another really interesting use case is pasture measurements, and it basically evaluating NDVI according to pasture and livestock movement. A lot of large grazing companies typically own these collars that they attach to livestock, and essentially the collars help drive the movement of the livestock, one, but then two, they now have the ability to actually evaluate vegetation health and track and move their livestock in a way that its grazing feels appropriately. These are really interesting studies that kind of tie into the regenerative agricultural movement and, kind of continue with our expanding and growing population. You'll start to see more sustainability and practices being implemented at the ag level. And it's really exciting because I think Planet serves and potentially has the ability to continue and emphasize and reinforce those methodologies. So I wanted to pause here, kind of make this the interactive bit of the piece, but what are we looking at over here? And this is where everyone can unmute / answer questions and yeah. Do you have a good look at it?
Yeah. Is this visual data or is this like UV data? Like what kind of data is this?
You're looking at like NDVI data specifically. But what are we seeing here? What's the kind of like that circle over there? What's the problem?
Well, it looks related to the contours of the land.
Could it be animal tracks or something? Yeah, like tracks of livestock, I'm guessing, if we're still on an ag kind of centric view.
It stops at the property line.
Be the fence line.
Yeah, the fence line, yeah.
Gotcha. Luciano, do you have any input on what you think it is?
I think this is maybe soil fertility issues, probably.
Interesting. Gotcha. So
soil viability or something.
The answer is everyone's correct or everyone's incorrect, however you might like it or not.
Correct.
But essentially Planet itself is a piece in the puzzle. Your in situ measurements, your instrumentation, other imagery sources that you're integrating into your solution, they're all going to play a piece in this puzzle that helps you create and produce amazing research. The most exciting studies we see with Planet data are studies that, one, combine Planet data and then use other data sources to kind of leverage proper insight. Planet, from a temporal resolution perspective, can tell you when something is wrong. It's kind of like a thermometer. You take your temperature, you realize your fever is 104, you have to go to the doctor. Planet can help with that. But when it comes to identifying what the exact problem is, it could be a multitude of different issues. It could be soil fertility, it could be grazing, it could be, flooding events. So there's a wide spectrum of answers that the issues could be, but having multiple sources of information really enables you to actually tell what's going on and produce a full picture. And having the ability to know something's going wrong. We've had many researchers at the commercial level acknowledge that their instrumentation on the ground hasn't detected something that Planet imagery has detected. So you just have a wide spectrum of different sensors, kind of instruments that your group is using, and really having the ability to combine the insights from each of them to, produce amazing research. So just to provide a little more context of the difference between open source and what Planet's providing. So you see to the right here, this is a field pictured with Landsat. Here's Sentinel, here's PlanetScope, and then here's Skysat. So when it comes to sub-meter resolution, you can kind of identify individual trees versus with PlanetScope, you can get a really good sense of general deforestation trends or agricultural trends comparatively. But that difference, I think, is so stark between Landsat and PlanetScope, and it really enables researchers, especially when you're talking about smallholder farms, when we start to talk about farms in Africa, India, LATAM, you're going to start to see very complicated plot designs that are a little less grid system-like that you kind of see with the states. So that difference, I think, is really unique, and Planet enables researchers and users to kind of zone in on that. So the really exciting part is here's kind of a coverage of Christmas Valley in Oregon and the States, and you can see the number of images that Planet has taken. There are a couple of gaps, obviously, with the clouds and then just the general coverage, but it's really exciting because you're looking at around 4 to 5 solid images every week. here's again a really, beautiful graphic that just highlights vegetation change during the harvest season. And it really shows, this stark difference in NDVI. And you can see the coloring and the red kind of becoming stronger. So to kind of dive into the category section of the presentation, where we kind of talk about, the geosphere, hydrosphere, atmosphere, cryosphere, and biosphere, it's really interesting to see kind of the wide depth and horizontal range that planet exhibits. You have over here the Palu landslides, where essentially planet imagery was actually used to detect kind of the geographical formations before, and then evaluate the actual impact and infrastructure damage for following the event. For many natural disasters, when you're talking about disaster response, typically the first image is delivered 2 to 3 days after the actual disaster. Planet has and gives you the ability to, one, develop situational awareness of what happened before the event, and then two, to understand the damages of the event literally a day after, which is really exciting. This kind of, quick temporal response for a researcher, I think, is truly unique and, really a testament to the ability and fast cadence that Planet images at. You have over here this study done that basically shows kind of flooding patterns. And then up here, you can kind of see this study done where they show the continual movement of the San Andreas Fault using Planet imagery again. This is my personal favorite section. I studied environmental engineering in college / atmosphere research. So I'm personally passionate about this, but this study over here was done by Tongshu Zheng, who's actually out of Duke University. And he essentially used the haziness in planet images to detect PM 2.5. He used a neural net and random forest approach and essentially created these maps that enabled users to identify pollution sources at 200-meter spatial resolution using optical imagery. These new novel methodologies are really exciting because it enables folks to kind of identify point source pollutants using methodologies that have zero kind of air quality tracking principles driven behind their collection. The kind of research and publication below is this really innovative cloud masking algorithm that also uses Sentinel imagery and Planet imagery in conjunction to kind of create these, basic cloud identification algos. You have over here the cryospheric research where, and this study to the right essentially maps out, and it's really exciting because Planet actually, when our PlanetScope satellites go up north, they actually image quite faster just because of the kind of overlap with a lot of the instruments that we have in the area, and the area being a little smaller, so it's just inherently a little easier to image. But researchers have found ways to essentially use Planet imagery and kind of the same day images, and sometimes there are multiple of them specifically within the cryospheric regions, to actually identify velocity rates of ice sheets as well as kind of ice bodies within a river or glacial lake. This is super exciting because it enables you to kind of create this velocity vector related studies that are kind of associated with Planet imagery in these really remote areas that can be tough to get to. And then over here, you have a lot of, I think, actually, this is the specific river velocity study. And, oh, apologies, Boreal Lake, Arctic Lake study, where they essentially use Planet imagery in Alaska to identify and track boreal and Arctic lakes. And there's also been this really innovative study that they did out of a university from Pakistan, where they created a neural net to identify glacial lakes, which is a huge problem within Michigan and certain other areas within the states that have more cryospheric environments and characteristics. This section in particular is really interesting. It's kind of our data fusion section. And we've started, and I think it's kind of the new hot topic within the remote sensing space, where researchers are using multiple data sources and kind of fusing the data sources together to extract the best insight from each of the sensors. What's really exciting and the role that Planet can potentially play in this is because of our temporal consistency, we kind of serve as the unified pulse and heartbeat. And and then everyone else kind of brings other things to the table, whether it be different sensors, as well as different, spectral characteristics and resolutions. So over here, this was a paper done out of the University of Belgium, and the researchers themselves used a neural net to kind of create this amazing data fusion product with Sentinel data. Down here, you have Professor Kaiyu Guan's STARS methodology, which essentially uses planet data, dove data, and MODIS data, drone data as well, to essentially evaluate and calculate leaf area index. And then to the right over here, you have Professor Jin Wu's forest phenology research, and he uses dove data with MODIS data as well to essentially track and map phenology within forests. So what's really exciting is Planet's one of the first companies to kind of pioneer this fusion space by creating this data fusion product that was actually derived from our education and research program specifically. So the algorithm itself used to be known as CSTEM, created by our very own Rasmus Hoberg and Professor Matt McCabe. And essentially the researchers themselves, they identified, and I'll point this image that, with data sources like Planet, you're going to kind of have near daily images, coverage gaps, haziness kind of come into the play due to the quality of the older sensors, cloud issues. So you kind of get this really complicated data set to use. So Planet acknowledges, recognize this. It's a problem we have partially played a role in creating. And one of the ways we've identified to solve it is to create this fusion product that actually kind of filters out the clouds, using mathematical algorithms, fuses the data sets, fixes the haziness, and basically gives you a daily mosaic. That's kind of the metaphorical way I like to describe it, or comparison, where you're getting a mosaic quality image on a near daily basis, which is absolutely exciting, because when you're talking about agriculture and, really understanding daily change, having these types of algorithms gives your users and kind of GIS analysts the ability to really just focus on the work that they're doing, rather than focus on the mosaicing, kind of data correction and fixing that typically goes into the workflow. So over here to the right, you can actually see this beautiful surface reflectance NDVI map, where you can see the data's kind of gap filled and essentially just, really analyzing and evaluating vegetation health. So what's really exciting, and kind of just to finish things off, is, Planet touches on so many different disciplines. You have the ability to study almost every, and we're starting to see some really unique and creative studies. Folks are using Planet imagery to rebuild archaeological ancient historical sites. You have folks using it to study geopolitical tensions. You have obviously the Earth observation community that's studying your more traditional remote sensing. You have folks studying agriculture, infrastructure, construction, energy, and it just touches on so many different parts of the world that it's really wonderful to see researchers play such a big role in kind of innovating and finding a lot of these methodologies that we can actually take back to the commercial world and use as use cases and proof points in a way that it's really innovative and shows that, this research exists, this is out there, this can help solve your problem. And then lastly, integrations. I think this is always a really relevant issue when it comes to, researchers getting tuned into working with newer data sources. So Planet itself has a plugin with ArcPro, with QGIS, and with Google Earth Engine. So if any of the groups and researchers work out of any of these platforms, you can kind of download our integrations from our developer center and then continue to kind of work with our data within your environments, rather than kind of manually downloading things and figuring it out afterward. So yeah, that's my presentation. I'll pause there for final questions, thoughts, and anything we want to cover outside of that.
First, thank you so much. That was incredible. I think it's really cool to, and from my background is more like history and archaeology and historic preservation stuff. And so I love that you mention and bring in some of those archaeological applications, and especially the mentions that you have about connecting or basically composite images with LiDAR, because those two sources together tell so much about the landscape and the past landscape. So I think my first impression was that there was a lot more research and publication focus in this presentation than I was expecting, and I really liked that. So.
Awesome. Yeah, no, I think we have a library of around 1,000, like it's 900 publications. I can see it getting to 1,000 in a month from now.
Mm-hmm.
And it's growing so fast that I think we're losing track of it. But I think that's a good problem to have, because it really, I think science really does help build out a lot of the things you see at the day-to-day commercial level and, you know, commercial innovation. And I think it's really unique because we do have a lot of, you know, education research programs. We're in around 50 universities. At the expanded programs, we have smaller programs, but it's giving students and researchers exposure to the data, so they can really take it, use it, commercialize it, and make it something that can help solve problems. That's, you know, at the end of the day, the goal and mission of the company. So,
would you mind just saying a little more about that program, or what those programs at university, partnerships that you guys have at universities look like?
Yeah, sure. So this is what we were chatting with Luciano about. But we actually have these expanded licensing programs that are kind of built for universities. One's called the departmental license, and then the other's called the campus-wide license. But they give countrywide kind of ability and scale within the programs, and they do it in a way that it doesn't cost like millions of dollars, which is really exciting for, you know, university researchers. Is you have the ability to accumulate, you know, around 3 times the total of the United States of America. That's roughly the size of the departmental license, and then kind of do like statewide monthly studies almost with that entire data, which is incredible. Like, it really gives you the ability to scale, do these fascinating research studies. I think recently, like NASA, they did a 10-day study where they fused Sentinel data with planet data to evaluate the crop yield of all of Togo. And they did this in 10 days, and they were able to do this within the program. So it's really exciting because there's just so much application. Things are growing so quickly. Universities are, you know, buying into it. And it's not just universities at, let's say, you know, the traditional remote sensing powerhouses. You're starting to see universities with, you know, like smaller geography programs, and archaeology programs, which weren't traditionally, you know, GIS and remote sensing fits, now starting to look into it because they now have this ability to really understand, you know, change for urban infrastructure. And you can even do that at the 3-meter resolution. You know, you can see how a flood impacts a community. You can see how bombings impact the community. You don't need, you know, sub-meter imagery to kind of do that, which is really exciting. And I'm stoked to see what else comes out. Like, every day I'm more and more shocked, and I think it's always for the good. So
great, thank you.
So
One comment about this, Uday. I think if you show them what's the big difference between the free Sentinel things that we already have with the planet. Because, for example, I'll give an example in precision agriculture. We are talking about making variable rate application maps to vary nitrogen application in a 40-acre field. So it's a tiny field. It's not like, and it's not like you know, that picture here, like the whole bayou kind of, you know, the marine or whatever.
Yeah.
That port. For example, if you're talking about pecan trees or, you know, almond, you're talking about farms that the fields are small. That's the big, I think, in agriculture is the big push for using high resolution satellite imagery. It's not in the level of tree, but I mean, we are talking about a field of 40 acres, 50 acres. Not if you're talking, I'm impressed that you show several papers, people using large scale, you know, large areas with planet scope. What's the need for that? I was thinking about why they are using a 3-meter resolution if you're studying a glacial formation or whatever in Antarctica, that you don't need that resolution to study the movement of, algae in the Gulf or those kind of things. So what I'm seeing that people are trying to explore more detail on that too. In agriculture, if you think about satellite remote sensing, there's no application because the clouds are a problem. One week gap, if you have 1 week gap between two images, you don't do nitrogen application anymore. It's gone. The timing, you lost the timing. So show them why daily basis, high res, the application of the differentiation between Sentinel or what Planet can provide us.
Yeah, Lucio, I mean, what you're describing is kind of our value versus Sentinel, right? In Sentinel, you're basically a victim to whenever it shows up. It's kind of on the routine, but it's not, it's like a bust, sometimes it shows up on time.
Yes, exactly. And it's not like daily basis, right?
So I think when you look at us versus like a free offering like Sentinel or Landsat or something like that, right? Our value proposition is first that it's a reliable daily cadence. We're capturing the same time, typically 11 to 1 within most of the at least continental US for agriculture, because that's the best time to capture given shadows and other issues, right? But because of the daily, right, you get a daily view. If there's clouds, then it just comes back the next day. Whereas like Sentinel, if you do get a cloudy day, well then, like you said, you're 2 weeks, 3 weeks behind perhaps. Also resolution, right? And so when you're talking about specialty crops or small hold, like coffee or something like, obviously better resolution also provides better kind of results on accuracy. And so that's, again, where Planet is. The one thing Sentinel, and some of the other freer sets of data have against us is the spectral band capabilities. However, with Super Doves now coming out for us in the next couple weeks, we have already 40 or so in orbit that we're commissioning. They should be live in the next week or two, is my understanding. That'll have eight bands too. And so at that point, then, I mean, I can understand if you want to go with Sentinel because of the band's capability and maybe build some algorithms off that. But now we'll have 8-band as well, and we can actually blend the two sets of data together, which we call our fusion product too, which is Sentinel plus our PlanetScope daily. So it's almost like the best of all the worlds.
Yeah, that's very good. Thank you, Dominic, to mention that. Since I work with remote sensing in agriculture, the spectral band is very important. I didn't mention that because sometimes, you think good image is one that's good for your eye. That's not true, right? Because for example, if I'm trying to see water content in the vegetation, I need a band that Sentinel does have and Planet doesn't have. So that there's several different use of different products. It's not always one is better than the other one. Let me see like that. So.
Well, I think that's what Uday showed is no matter what you're doing within remote sensing, the more data you have, typically the better your result. So you can take drone or LiDAR or something and pair it with satellite, then you're always going to get better results. And so it's not really, at least in our opinion, it's not really like an us versus them. It's how we work all together. But you're absolutely right in that, I wish you could talk to some of our commercial customers and tell them it's not always about what you can see, but it's actually about the analytics that you can derive from the data. Because that's very true too. It's actually the power of the data and the spectral bands plus resolution plus cadence. It's all three of those together, which is what drives the value for Planet within research or commercial. Like Uday said, Yeah, I guess I should just tell you, I'm our global sales development director. So that's why I kind of see both sides of everything. We've developed a lot of commercial products, like Uday said, based off of actual research, right? And so we see like, okay, wow, these researchers did this really cool study on whatever it is, whether it's like, irrigation, at field level, or whether it's like tracking, like Uday said, like coral, offshore. There's all these different things that then, okay, we see that there's a lot of interest around this in the research community, but also the commercial community, and then we can build products off a lot of the research. And that's why we offer these licenses at such a discount, is because first it gives the research community access to this resource at a severe discount, but then also because it benefits us in the end too, because we understand all these different new potential use cases that come out of these almost free in a way licensing structures.
Yeah, one